for today, and we can actually see what was done last time. Yeah, group chat. I think you tried to do it last weekend, actually 2 weekends prior. If you have it, please share with other students in class. If not, you can always create it. So anyways, we looked at only one section last time, section 2.1, introduction to the functions. And in order to get there with this textbook, you just need to click on section 2.1. I guess it's pretty convenient textbook. I was very happy I was able to find it for you. So let me refresh what we talked about last time in class, which I also recorded and emailed to everyone. So we looked at the various functions. So when you are working with function, then you need to realize that function does not connect 1 point to 2 points at the same time. So like in exercise number 16, when you connect Bob to 2 different ladies, it's not a function. I say, but could this be possible? Yes, of course, but from point of view of function, it's not a function. So even though one can say, yes, one father can have 2 daughters, but if you're talking about functions, it allows one only or none of them. I say, this is pretty odd. Well, yes, that's, I guess, the way it is. So functions and not functions. So we also looked at various ideas of having a function, and one of those is being able to see, like in exercise 27, y on one side. In other words, to be able to write it as a f of x. So whenever you see y on one side, then you can replace it with f of x. So y is a function of variable x. That's what this stands for. I hope you saw this before. It's a very popular way to describe functions. So function is something. And if y is isolated on one side, well, then you clearly see that you have a function. In fact, here's the graph of this function. It's a parabola, so-called U-shaped curve parabola. That's probably the most popular graph that we will see a lot in this class. So functions. So whenever you see y on one side, like in exercise 36, you see letter y, it doesn't really matter what it is equal to, it's a function. If it's a one equation only, then it's a function. On contrary, exercise 33 is not a function. 33 is not the function. And the reason is that you have a y squared on one side. And it turns out that if you try to graph that equation, which is not y is equal to x squared, but x squared is equal to y, then the way it's gonna look, it's gonna be also a parabola, but now it's gonna go along x-axis. The previous picture, I had a parabola that opened along y-axis, but now when I switched the, let me write this a little bit more carefully, x with a y, so notice that I used to have y is equal to x squared, and now x is on the left side and y squared is on the right. So switched letters x and y, and that's what makes always graph to switch. Instead of going along y-axis, now it goes along x-axis because we switched x with a y. And this is not a function. Why not? Well, because looks like same exact issue happens with this graph. For example, if you take a point x, notice that the graph will bring it to some value of y dot x, but also the lower part will bring it to the other value of y. So I can say first value y1 and the second y2. So if I have just like in 16 1 x that corresponds to two y's, to y1 and to y2, that's no good. That's not a function. It is possible, anything is possible, but we say it's a relation, which is not a function. And in this class, we'll be working with functions. We're not going to work much with relations, even though we'll encounter some of them in here. And here's an example of not a function that we just encountered. So that's one thing that we have talked about last time. And then the other thing was domains and ranges for those functions. And that came in the next group of exercises that was dealing with finding domain. It turns out so-called range we don't really touch much, but domain is always on the x-axis. Like, for example, in the previous case, when I looked at the not a function situation, I can see that domain here will be starting at 0 and extending all the way to the right. Which is it possible to have a domain? It's not a function. Oh yeah, it doesn't matter if that's a function or not. You can see from the graph that domain is all positive x's, including zeros. So for any number x on the right side of the x-axis, on the right side from 0, you will get some point that corresponds to the graph. So the graph will actually have 2 points all the time, right? And that's not a function. And that's the idea of domain. What are the possible x coordinates of the points on this graph? It looks like they only greater than or equal to 0. I say, it looks like we approached this a little bit differently. Looks like we used to consider the cases when we had the we can exercise 56, something like a square root. Yes, exercise 56 that has a function. So now they clearly say that's a function g of the variable letter x, and it's a square root extracted from 1 minus x. So what we did for finding domain, we noticed that that whatever we extract the square root from, and that's our so-called radicand 1 minus x, cannot be negative, right? So it's greater than or equal to 0. And that tells us that x is only less than or equal to 1. What I just did, I brought x over to the right side and produce a domain for that function. And that's what should help us to produce a picture. Just like I did in the previous exercises, I graphed those parabola-like functions. And it turns out that the main here will also help me to graph this parabola-like function, which is actually going to go to the right, because notice that x is from 1 all the way to the left. So looks like the main has a graph with x coordinates that extend to the left. We will work more with square root functions today. So just a little flavor of how the graph going to look like. And let's see another case here. Remember, there was another possibility for the main when we encountered denominators. So we considered last time two special cases where we needed to worry about those domains. So the first case was function like we had here, and the second case, the one that is called P of X. I say, why do they call them with different names? Can't they just use f of X? Well, I will always use the same name, but they just trying to show you that you can use any name for the function and it doesn't really matter. It's pretty much the same thing. So this is the exercise 59 that also asks to find the main. And here, I already see that we have a square root extracted from 2 over x minus 1, which is supposed to be greater than or equal to 0 because of same idea that we just encountered in the previous case, right? So when we had square root extracted, whatever radicand is, it's never negative because you don't square root negative numbers. It must be only positive. So if this is greater than 0 or equal to, then how about, I didn't ask you to put your student IDs in the chat because that's private information. Student ID, social security, your address, your phone number. If you want to share it with everyone in class, you can do it, but you don't need to do this. In fact, I never ask my students for their student IDs because I don't think it's useful, because when I say give a test or something, and if you just give me your student ID, it's very hard to find you. Just looking at this student IDs, there's so many digits, it's kind of annoying. But I think it looks like a phone number. So phone numbers you can share with each other. That's fine. I think that's a good idea. But no, not student IDs. You don't need those because you don't want to get other students to have access to your private information. Well, anyways, no, I don't collect attendance in chat using any approaches, but at the end of the lecture, I usually give a little quiz just to see that you are here with us, not somewhere else. That's the idea. But anyways, maybe I didn't get the point, the question, but just I think good to know for in general. And also, since I get off point a little bit, I see some more people were able to log into Zoom, and I want to share with everyone once again the link to the free textbook. I think that'd be very helpful. So I just put it in the Zoom chat, the link to the free textbook, and that's what I'm using right now. We're actually on the page 90 of this textbook. So if you click on it, the fastest way to get to where we are is just put 90 out there and this PDF file. And that PDF file you should also download to your device, because this way you will be able to click on that icon and use it at any time you want. So just make sure you download it. It doesn't have any viruses, no worries. This is PDF file, right? That's an extension of that file. So anyways, let's find the domain of this, right? So how do I find domain? Well, I need to find x, and since x is in denominator, we usually try to put this in numerator somehow. And notice that here, in this case, I need to have x minus 1 to be a positive number because 2 is positive. And the quotient of these two numbers is also positive, and that's why I need to have my denominator also positive, because in order to get the positive result, I have to divide two positive numbers or possibly two negative numbers. But since numerator is positive, then my denominator must also be positive. So I have something like x is greater than or equal to 1, and that should help me to get a graph. But on the other hand, x cannot be equal to 1. Please notice that if x is equal to 1, then we're going to have a problem with a fraction, right? 1 minus 1 is 0. We don't divide by 0. So what I can say finally for domain is that my x is just greater than 1. No equal allowed. So anyways, that's the idea of these exercises. And again, domain is helpful to get a graph. And later we're gonna use this, of course, but not much at this stage. So I'd like to move on to the next section that actually talks about the same exact thing again. Like, for instance, in example 1, they're saying that these two last graphs and the one that we just produced, remember, there was example x is equal to y squared, is not a function, and we already know that. And they say it's not a function because the vertical line will intersect it at 2 points. They actually produce the vertical line. You can see this broken line here. And they show that there are 2 points of intersection of vertical line with this parabola. And that's what makes it to be not a function. And we actually just saw even why, because that vertical line will send one value of x into 2 different values of y, right? And that's what so-called vertical line test is. So analogously with a circle, you can see they're able to find a vertical line that intersects this at 2 points. So it's not a function either. So it looks like these two graphs are not for the functions. They're just relations between x and y. And similarly, from this perspective, on the figures A and B, those two will be functions because they don't have such an issue of having a vertical line intersecting their graph at 2 points. No matter what vertical line you can possibly think of, you will get only one intersection. So you can see that these two graphs, and A and B as well, will be graphs of functions. And that's not really surprising for us because we can see that y is on one side is equal to some with x on the other side. So when you're able to have y replaced with f of x, then algebraically you have a function. So it turns out this section does not really bring us any more information. And that's why I want to take a look at the next section. And then I will return to these ideas a little later today. The next section is something I want to skip. So I want to skip section number 3 in chapter 2, which means that You don't want to worry about it at all, as if it does not even exist. It turns out that I selected the textbook called Pre-Calculus because it was free. And we're having a college algebra class. So pre-calculus is a same thing, but has a little bit more units. So it has a little bit more information compared to what we need for a college algebra. And that's why there are a few sections that we don't need, but section 2.4 is something that definitely is useful. And to do this, I guess I need to get some room now. So what I'm going to do is just erase all the mess that I produced so far and look at a graph that should be already a little bit familiar. Here it is, the function square root of x. Remember, we already encountered something like that in here in exercise 56. So it turns out that the square root function is a very standard graph. It starts at a point 0, 0, and it extends to the right and looks like a half of the parabola. So what they did, they calculated a few points and used them to picture that parabola, like actually a half of parabola. The reason it's not the whole parabola is because if you decided to put the entire parabola open into the right, remember it was not a function. Let me show you. If you put the entire parabola like that, and the equation of that was x was equal to y squared, right? Then there was a vertical line test, and there were two intersections, and that was not a function. So what they did, they extracted square roots on both sides, and they produced a graph of y is equal to a square root of x, and that is a function. And the graph of it, though, is just a half of the picture that we already saw before. So we kind of artificially making this to turn into function, so we can put it in our so-called library of functions. That's how this section is called, library of standard functions. And one of them is a half of parabola, the square root function. So turns out that a friend of it is a cube root function. So if you take a look at the next picture down below, then you will see there is a graph that they again produced using a bunch of points, and the graph looks like a parabola, and there is another half of it that goes kind of to the left, and this happens to be a cube root of x. So notice that this previous graph did not have this extra part, but the cubic function, cube root function does. And again, the explanation to this is they give by using a bunch of points, so you can look at it. But I guess our goal is to be familiar with the facts that square root and cube root are kind of similar to each other. I know you may see it first time, so you'll see it again and again and eventually get used to it. And that's the idea, to look at these standard functions to get used to them. And now I'm moving to the, let me move to those here, the ones that we already saw today. And those are nicely put together on the next page. And this is, of course, our already familiar parabola x squared. right? That's our U-shaped curve, so I can draw it again. We'll draw it again and again. We'll draw it so many times that you will, I don't want to say get sick of it, but you will really remember it. So that's parabola x squared. Notice it's somehow related to the square root function, right? Because square root is half of this parabola only. And cubic parabola, the one that looks like a similar function somehow to the cube root from x. That's y is equal to x to the third power. So I think it's good to stop for a moment and observe those graphs. See, they resemble somehow each other. And I guess that's the key idea of pre-calculus. We don't want to graph anything using points. We want to look at the equation and technically remember that the shape of this is a parabola, and that's how we are going to graph. This method is faster, and it also enables us to get more complicated pictures. So one more graph from the library is so-called absolute value. Y is absolute value of x. That's the one that I just skipped, and I want to return back to it because that's another popular function here. You can see it in example 2, and that's so-called check mark like function. This is the absolute value function. So that's another curve that has place in our library of functions. So that's the one that we will be also working with throughout this chapter. So let me look at some of the exercises, and this way we'll start to better get used to these functions. And in this section, I'd like to just look at the first few problems up to those so-called piecewisely defined functions, because that's something that we don't need again for this class. As I said, it has a little bit too much of information. So just without this grouping symbols is what I really care about. Like, for example, what about number 17 exercise? So remember that for this class, I asked you to do some of the practice problems. And the practice problems are at the end of section, just like in every textbook in mathematics. So I went to the section end, section 2.4, to the end of that section. And we only care about so-called skill building exercises. So for the homework, skill building exercises are good enough. And for this particular section, I want to just look at these problems in a skill building. So if I, for example, take a look at exercise number 17, that has a graph of function f of x that we can always call as y, which is equal to letter x. Notice that this is a graph of a line when x is the same as y. If you remember how before you used to graph those various equations, you had to put some points for x and for y. So if I use, for example, 0 instead of x, well, then y is also going to be 0. If I use 1, y is also 1, because they're the same, because x is the same as y. If I use 2, y is also 2. If I use -1, well, again, they're same for x and for y. So if you try to plot those points on the XY plane, you will see that they all are on the same line. And indeed, y is equal to 1x is a line. And you can actually see the graph of it here in exercise 13. So this group of problems actually says, what if you have the line, and that's like a graph of this f of x. Okay, how about number 18 exercise? X squared. Well, that's our parabola that we just placed on the left margin of the page. And here's the graph of exercise number 18. So technically, these problems are so-called library of the exercises, and goal of them is to be familiar with that library. So just this little part of the section actually continues in the next one, in the section 2.5, and that's what I want to look at in more detail today. So that'd be our last section for today. So let us see what they are doing in here. And they talking about moving those graphs up and down. So when I consider the first example in that section 2.5, actually it's a second example, they are talking about, again, the graph of favorite parabola y is equal to x squared, and that's the one we're already familiar with. But then they asking, what about function g of x, which is x squared minus 4? X squared minus 4. And notice what they did. They took this parabola x squared and they moved it down by 4 units. And that's not a coincidence. If you subtract 4 from that x squared, the whole picture goes down by 4 units when you subtract. I say, so if I subtract 2, the whole picture is going to go down by 2 units, like in the next little example. And the answer is yes. Notice they have that y3 that is moved down, that is same parabola, but moved down by 2 units. And that's a very interesting observation here. And it is also very useful for graphing. So whenever you have parabola and some number added or subtracted from it, then you move your parabola up or down. Like in the example here was a x squared plus 2. Now your parabola is moved upwards, so it looks like it is 2 units up, right, on the x-axis. And that's the key idea in here. So let me actually do some exercises related to this ideas at the end of the section. So I'm gonna scroll down a little bit where the skill building exercises are, right? That's what we're after. So at the end of the section, as usual, you can see there are lots of explanations, which is great. Now you can see the so-called skill building exercises for section 2.5. And in a part A here of the first group of exercises, I'm looking at x squared plus 2. So let me get a little bit of a room here. Maybe I can just clear this right side for now. So here I'm going to get the equation of parabola, which is here on the left side, y is equal to x squared, but with one little extra. The number 2 is added to that entire x squared. And this causes my parabola to move up. So the graph of it is probably going to look somehow like that. And indeed, whenever you add a number to your entire function, this looks like parabola moved up. And notice that's 12 that corresponds to this particular idea. So when you have 2 added with your entire x squared, you move it up. So that's one of the observations to make. And turns out there is another transformation that is very popular with parabolas. It's to reflect picture through x-axis. So if you put a negative in front of your x squared, if you put a minus, then parabola is going to be, people say, reflected as if the mirror was going along the x-axis. Interesting, right? So reflection. And I guess B has something to do with this. So let me write this down. B is y equals to negative x squared and plus 2. So notice that now the parabola that I'm working with is going to be negative x squared, right? Because we have a minus sign. So what happens with its graph? Well, similarly to the previous example, we also added 2 to the whole thing, right? That plus 2, which means that the whole picture also shifted 2 units upwards. So that parabola, the green one from that left side, is the one that opens down, was actually brought up 2 units. How about that? So I guess that's very important to observe, that we technically don't care if you deal with x squared or negative x squared or with any other function. You add 2 to it, it moves upwards by 2 units. And that's it. You subtract 2 from it, it moves downwards. So this is, I guess, the key idea for this section. Well, turns out, besides moving your graphs up or down, you can also move your graphs to the left or to the right. So I just want to work with parabolas today so we get used to them better. And I want to take a look at the exercise number E here that says x minus 2 in the parentheses squared. So please notice that this is not the same compared to what we used to have before, because the previous example had 2 added to x squared, but now we don't have x squared, we have it being done inside the parentheses. So what changes if you're going to put inside of your parentheses that minus 2? And it turns out that what happens is that graph is going to move by 2 units to the right. So this is going to be right or the left shift of your parabola. Since we still have squared involved, then it's still going to be a problem. So we moved it to the right because the 2 was subtracted inside of parentheses. And one can say, well, we subtract, so we should move to the left because we make it lower, but Actually, it's the opposite. And the reason is that we have x minus 2 in the parentheses. So the first thing you do to your x is you subtract 2. So you kind of return back your parabola to the origin point, and that's exactly what gives us that original graph of y is equal to x squared. So you're returning your graph back when you have number in the parentheses. So it kind of behaves the opposite to the common sense. One may say, well, I guess that's the way it is, and the actual picture of it is right here. It's number 8. So I've got the result number 8. That's the picture. So it looks like this section wants you to find the corresponding graphs to the equation. And why don't I do part F of the exercise and deal with another parabola, which is also having in the parentheses x plus 2, just like x minus 2 in the previous example. But there is also minus, so the graph is going to be pointing down, right? Just like we already saw here in the previous example, where the graph was opening downwards when we had negative in front of that square term. So anyways, we'll keep this in mind, and now I'm going to have the parabola moved to the left. So the parabola will be dealing with -2, because again, we had in the parentheses added number 2. So it went instead of right to the left, the opposite to common sense, one may say, because the previous example, we had x minus 2. So we went upward to the right by 2, right? And now it's plus 2. So now we go to the left by 2. But the graph also has to be flipped. It has to open down, right? Because there is a minus in front. So do I see the graph that resembles this particular situation here? When you say, I don't see it among these ones, maybe I can see some more. 15, isn't it? Looks like number 15 has the one that I just produced down below. Okay, so we see that these parabolas could be moved up, down, left, and right. So that's the key observation I wanted to show you today. And next time I want to continue with this. I know this material is not very obvious, so I think it'd be a good idea that over this next week, you give it a little bit of a thought and look at these ideas again, and we'll have more exercises done in this section. And now, as promised, I will return back to the story of previous section. I believe it was 2.2, where I told you that I will come back with, because I want to take a look at some more exercises in that section, and they deal with word function. So if something is a function or not. So 2.3 is we're skipping, so 2.2. So let's look at the graphs in 2.2, actually in the skill building exercises. And what I want to consider is a couple of problems that deal with this so-called vertical line test. That's the main idea. And you're wondering if we have a homework, and the answer is yes, of course. Every section we do is for the homework. And let me maybe clean this a little faster. So just stop sharing and then share the screen again so you can have no mess in front of you. So far, what we did for the homework was section 2.1, and that was done last time, and today I discussed this a little bit. I also talking right now about section 2.2. Then I skipped section 2.3, and then we considered a little bit of section 2.4, and the section 2.5 that I stopped at, that's the one that I'm going to talk a little bit more about next time. So 2.1, some people already did, and that's great. So right now it's 2.2 and 2.4. So I'm doing the exercises from section 2.2, and you should always do similar problems to what is done in class. So you don't have to do problems that I don't consider, and similar problems are from skill building exercises. So that's the key idea of all of the exercises. Look at the only group called skill building, and not every single problem. We're being selective here. That's why it's a good idea to see what we are doing in class. And if you happen to miss a class, it's not a big deal. I record lectures and I email the recordings of every single lecture to everyone in class. Just check your email. It was done a couple of weeks ago. We did 2.1, but today I went over it again. So technically you don't have to worry about that, and just look at 2.1 in today's lecture recording. Now, again, you find all this information in the textbook. So the free textbook that I found online, I can share the link to it once again. So I'm gonna paste this to the Zoom chat. I just did it today already twice. So somebody just came in, so I pasted again. So make sure that you save this textbook, because I know that people just love to ask me by email, say, Alex, can you email me the textbook? I'm not allowed to. So all I can do is just, when you're in class, take this link, and when you're on the Zoom, you can ask me, I can always share it with you, but I'm not allowed to send it by email. There are copyright issues. So you're asking, so we just do section 2.1, and the answer is no, not just 2.1. 2.1 we did last time. Today we do 2.2, 2.4, and 2.5. So we do 1, 2, 3, 4 sections. In fact, I already told you that some people did section 2.1 already. So today we're adding a little bit more. And the next time we'll add a little bit more material on the top of it. And everything we do, you can see in the recording of the lecture. And I will email you a recording of this lecture a little later today, in a few hours usually, because we have that Zoom program that needs to convert this to nice video, audio file, and that's why you want to email it, that I email you in a few days. Now, how do you turn in the homework? That's a good question. So we're going to have a first little exam, the midterm, in a few weeks. So let me look at the schedule here for the semester, and that be the day when the homework is due. So let me go to the calendar for the year 2023. So here it is, the standard one. So it turns out that we have a Saturday class, and since we decided to use Zoom, in fact, I think most students really wanted to do it on Zoom, because I can give you the tests also on Zoom, so you can take it on your own, not in the classroom. So we started our class, today is 25th, so we started on the 11th, right? And there was a holiday on the 18th, so we didn't have the class on the 18th. So today is technically like a third week of class. So there'll be a fourth week of class. We're gonna do some more material. And then on the 18th, I plan to give you a midterm. Because it'd be in the middle of semester, because midterm is in the middle of semester. And that midterm exam, I'm going to email to you. So I'm going to actually email you a practice midterm before. So on the 11th, we're gonna do the review. We're gonna work out that practice midterm together. So you will see what problems I put on that midterm and what you should do to solve these problems. So you will have a very clear picture of what to expect on that midterm exam. And then on the 18th, I will also email you midterm exam in PDF format. So you just click on it and it opens. And I'll give you plenty of time to do it. So you can take the whole Saturday. I say, Alex, Saturday is just too much because Saturday I have planned. I go to some place. Well, whatever, you can continue with it next day. So the point is, I want to make sure that you email me picture of your work. I'm sure you'll email pictures to your friends and family. Just get a camera and make a picture and you send the email, right? Attach with a picture. So on March 18 will be a midterm. Of course, it is Saturday. So I will expect you to do some problems. I usually don't ask a lot of problems. I ask for 2 problems. So 2 problems. I say only 2? Yeah, 2 will be good enough. Not hard problems. It's similar to what we're doing in class. So make a picture of your work and email it to me. And again, since we are doing it in kind of online format, there is no time limit that I set, so you can take the whole day for this if you want to double check, triple check, or sometimes people say, Alex, I had bad internet connection. Fine, email me next day. I hope your internet eventually will get connected pretty well. But I need to see this homework also on that day. So for now, you just keep working on chapter 2, and the next time we'll probably start working on chapter 3. And somewhere in that area we'll stop, and that'd be the cutoff for the homework. I know some people just started today with this class, and it's good that you're here with us. And now you know what to do for the homework, so you can start with it. And next time, when we be again on Zoom, you can ask me questions to do any problems from these sections that I covered. In fact, I will do it again because remember how I started this class? I started it with doing problems from section we saw 2 weeks ago, section 2.1. I know it's been a while, so most people may not remember much from it. So that's how I start every class meeting. I refresh your memories on what we did the previous week. So this homework, you should also make pictures, or you can scan it and email me that scan. Some people say there's other ways to do it online. There's some other applications that you can put in the cloud and share the cloud link with me. So any way you like. So far, I was able to open all of your emails, all of my student emails. Just do something and make pictures or scan it and send it to me by email. And please do it on the day of the midterm. So you still have plenty of time before the midterm because it's middle of March, right? So that's the idea for the homework. And analogous thing we'll have for the finals. So our final will be at the end of April, right? So it'll be same thing. So there'll be another little exam and another homework package too. So we'll of course discuss that, and I'm sure you'll be pretty clear on all these procedures. And again, I guess advantage for most students is that you will be able to take this in online format without supervision. And of course, there's always disadvantage that you need to know how to make pictures and to attach them to your email. But I'm sure that's the part that you already know how to do. In fact, if you don't, it'd be very good and useful learning experience, because in the real life situations, they always want you to email them something if you're looking for the job where you want to email your resume or fill some application and email it. So you need to be able to make sure that you know how to email and attach application or letters of reference or transcripts to it if you're applying for some position, right? So I think it's very good learning experience. So anyways, we'll always discuss that. If something comes up, you can always email me, because I know that it's a whole week break in between the class meetings, so you might be forgetting something. So I'm available online every day, pretty much few times a day. I read my emails and I will do my best to answer. So don't hesitate. Anything comes up, I'm glad you're asking questions. You can email me your questions. And there was another question, so you can do a couple of questions from skill building sections. The answer is yes, that's what I said last time. So for the homework, what you actually do, say do a couple of exercises. In each section we cover in class. So far we covered, looks like 2, 1, and then 2, 4, and 5. Well, I just talked a little bit about them. You can try to do a couple of problems in each of those sections. And don't throw it away. Make sure you keep it. And then when time comes, you can make pictures and send them to me by email. And in fact, that's what I do in class. I do a couple of problems, even more than a couple of problems from each section. So you can clearly see how to do problems by looking at the recordings or just by being here with us. So anyways, I'm glad that you are still here with us, because I plan to give you a little quiz today. You will see what that means. Let me do a couple of problems first here. And what I want to do is not answer that question. I want to just see which one of them is a function or not. So for example, the graph of exercise 11 is going to be not a function. And what determines that is a vertical line test. As long as you can find one vertical line that crosses at 2 points or more, your graph, you don't have a function. That's the idea. So exercise number 12 is a function, because no matter what vertical line I'm thinking about, the vertical line intersects any piece of my curve only once. So it's a function. One intersection, function. 2 intersections, no function. That's it. So what about number 13? They recommend to do number 13. Is this a function? The answer is yes, it is a function, because the vertical lines intersect only once. Well, you say, Alex, but what about this vertical line? It doesn't intersect at all. That's fine, as long as you don't have 2 intersections. So how about problem number 15? Is this a function or not? Well, I can see a vertical line that intersects at two places, so it is not a function. You're absolutely correct. So I think that's pretty nice and straightforward type of exercise. So now I would like you to tell me if it's yes function or not a function without a hurry. You can put your answer in the chat, but don't send it to the whole class, please. Only send it to my name. Because if you produce the wrong answer, and if you send it to the whole class, well, other people may get confused and say, why is this student confusing us, right? And that's why you want to make sure that you only select my name. In other words, don't hurry. Because if you hurry, say, oh, let me do it right away, just quickly, yes or no. No, don't hurry. First of all, select my name. In this blue box on the chat, there is a name that you can choose. You just, this little arrow that points down, you can send it to everyone, or you can send it only to me. And some people already used it. That's very good. So let's do quiz. So looks like you like exercise 16. So let's do quiz for exercise 16. So all you need to tell me, is this a function or not? Just yes or no. And once you answered yes or no, this is it. That's our little quiz for today. And that's the level of quizzes I'm planning to give you. They're not going to be hard. I'm sure you're going to like them. And again, it's designed to make sure that you are with us, that you follow what we're doing in class. And that's why I always give some nice exercises for the quiz. So if you're done with the quiz, if you already gave the answer, then you can log out and enjoy the rest of the day and have a great weekend. And if you have any questions to me, then please ask, because again, our quiz is exercise 16. So I just wondering, is this a function or not? So function or not a function? That's all I want you to answer. Put this in the chat. That's where you put it. And once you put this in the chat, make sure that you send it only to my name. Don't send it to the whole class, please. So only select my name. That's what means not to hurry. When you do math, you don't want to hurry. You want to just make sure you do it right. That's the key idea. So once you're done with it, you're welcome to log out and enjoy the weekend. And we'll meet again on Zoom next Saturday. So we will continue working with chapter 2, and then we'll move to chapter 3, and that'd be the plan. So, oh, okay. I'm glad that you were finally able to log in. That's very important that you know how to log into this class. I'm glad that you were able to. So thank you for coming. I know that sometimes it's hard. You need to log out of all of your other emails, go to your student MDC email, and then the computer will be recognized by Zoom, because that's how they designed this login thing. Have a good weekend. Thank you. Thank you. Bye-bye. Have a very good day. Bye-bye. So again, if you haven't done this quiz, we're doing problem number 16. So make sure you put the answer, and that's the answer in the form yes, no, in the chat, either yes function or not, no, not a function. And once you have this placed in the Zoom chat, that's it. That's, I think, good enough for today. So you can log out, and we'll continue with all that next week.